password is password is the password is
get going. All right, here we are. Check, check. Camera on, camera off. Fast displaying of things. So, this is the eighth day. I just increment the day every time, or I change AM to PM depending on if it's a day or a night stream. So, here we are. Today is September 6th, 2025, and we're making a game. Here's a to-do list. You guys like to-do lists. We'll start off, as usual, marking off all the things that I did since last time we streamed. Wow. Today we're going to do my to-do list on the left. Not in any particular order. This is just sorted by date. And they all have the same date. E, F, G, H, I, J, K, L, M, N, O, P. It's not in alphabetical order. It's by deadline. And then not alphabetical. So, the reality is I'm going to actually work on one of these first. And I believe it was tab toggle. I want to show the ping for the server. So where are we at right now? I've got a program that lists all the servers. And then I've got the game server. We'll put this on the left. We'll put it here actually so you can see it. And then I have here a client. And the client has a ping now. Okay. I've synced the server time and the client time. Every time there's a ping update, which is every second, we get the latency. Now, latency is important. I'm building a action game with some RPG elements. So, knowing the exact time of things can help with simulation. And instead of having to wait for the server to tell you that you've done what you've done, we're going to assume that you've done what you've done. Everything except killing the other players. So if you're nowhere near another player and we pick up coins, you're getting the coins. But if you're far away, if there's another player nearby, then we're going to go and look at your packets. And when we receive those packets, I'll probably put in a limit. If you're like over, half a second late. So let's say half a second is the limit. I don't want you getting an advantage for having a 500 millisecond ping. Okay? This ping number is how long it takes to hit the server and get a response. So to hit the server is 8 milliseconds. And I'm local too, so I have enough overhead between each frame that we got 16-second ping on a LAN. It's not the end of the world. I'll go do a test later and see how bad it is for the other users. The reason why I want the ping on the server is so that I can know the average ping of each client. First, we're just going to do fully accurate ping, or rather the last ping, and then I'll start averaging it. I'll probably do a running average of a minute worth of ping, so that it'll just keep resetting. Or I could go really wild on it and just keep the total ping. I'll probably do it this way actually. Now I want to average it over every few minutes. And it'll be like a rotating average. So you'll have like 60 seconds worth of ping updates. Or maybe I would say, I guess if I'm doing 5 minutes, you have 5 minutes worth. And then once you get to the end, it just wraps around and replaces. And we'll just keep going. Now, this isn't hard, but the work has to be done. So I'll start with the ping, showing the client ping, which is really going to be a walk in the park. Foreshadowing, not. Now this will be easy. So let me think. When I receive information from the user, it goes back and forth. I've got it to where we've got the ping. I still need to receive a packet from the user that says how long. Right, so I've got it going back and forth once or twice. So let's just do p client. So I initiate the ping to the server. The server sends back the ping init. The client sends ping done. And then the server doesn't have to send the ping done. So let's see if we're processing ping done. Nope. Great. We have everything we need here though. And when we do the init, I could store the client's last game time, the one that they send us, and I could store that in the client packet. So let me, or the client, player client. So let's do that. So I should have a player clients here. Yep. And then I want to do ping. And then we'll do another one, which is last game time. So last time that they sent a game time update via a ping. So it's gonna, I'll call it ping last game time. And then I can use that information on the init in here. And I'll get that. So client to server, yes. So this is where I would store it. So we'll get player client. I think I have a method to get this. Let me see if I have one. I think it's going to be called internal. Internal entity ID from peer ID. That's not what I want. I want player client from peer ID. Yeah, okay. So I don't have it. But I know I have a way. I mean, this is basically it, except returning a different thing. So let's get player client from peer ID. Go through that. And instead of returning that, we want to return a pointer. And then that, get rid of this. Okay, so I think we're good here. That'll get me the player client. Interesting. So I'm not defining these up at top. I will start. Oh, I am, but I wasn't defining that one. That's funny. Okay, we'll go back and we'll get that one in there too then. So this one. Okay, so we're gonna use this in here. So the client does a ping init. We know about it. We need to fetch from the peer ID. I have the peer ID from the packet. All right. What are we doing? Game player client. Great. We are good to go. And then we'll do player client dot if player client does not equal null, we will do player client game time, last game time equals game time. Perfect. And then in the done section, we'll do the same thing. All right. So we got it. So with done, we don't need to do this, but instead we need to update the ping. The ping will be it's game time minus player client last game time. All right, great. And now we need to set the inits for these things. All right, we're gonna iterate through the player clients. We are not initializing any of their information here. We will change that right now. We'll do capacity, game player client pointer player client equals game state pointer player clients with items plus I player client ping equals 0 player client ping last game time equals 0. Great. I think we have most of it. We are missing something. What are we missing here? Player. Okay, so we are defining this later on. Interesting. Yeah, these structs need to go way up to the top. Eventually they can go in a header file, right? Okay, and now we're missing player client, multiple initializations, so that's fine. We'll just put you up here. Great. Okay. So now, client to server ping done is the last thing that it sends, but it doesn't because we haven't implemented that on the client end. So let's do that. So here we've got GM update, go back and forth. So I would need to do the server ping init here. When we receive this packet, then we need to send out another packet in here. So let me see what we're doing. I'm just looking to see if we have a packet code here. Yeah, this is good enough. We'll steal that. And then here. So now the client's going to send one more packet back to the server, and we're going to say done. Great. And then do I need this? I do not need this. And I just need to send a packet with the game time, which is all this. Okay, I believe we're done. So we'll send ping done. We get server to client. So am I doing this wrong? I am totally doing this wrong. This is ping init. Ping init is going to send, I need to send something to the client, so that would be p client. Am I messing this up? The client is going, yeah, client should be sending ping done. Okay, so here to here, we got ping done. Now we needed to set up ping done for the server. So let's do init ping done. Yes, this is where we want to be. Okay, and then we don't need all this stuff. Oh boy, I'm really concerned with what I've done so far. Okay, that's fine. Now that we have init, we've received a packet from the client. We're sending up our last ping. Okay, and then when we get ping done from the client, I already have a case statement for ping done. So what was I just doing? Yeah, that doesn't go here. Interesting. Let's see what we're doing in the server. In here, I've got init, and then I've got client to server ping done. I think I'm sending the wrong packet. Yeah, this should be a client p client server ping done. There we go. So now the client sends it to the server that the ping is done. We receive that the ping is done, and here we are. This is where we want to end up. Too many arguments for call. Yes, we don't need the peer for the server. And there we go. Okay. Should be good. Gonna set up all of my other things. So let's close all this. Run. We're just doing a crash check. Okay, we're not getting any crashes. That's good. Next, I want to print out the player ping. Okay, this is server. The server's the one that's going to print out the ping. So I'll put that here so we can see it. And we'll move the server back over here. Okay, they join. And we've got the ping. Now, the great part is the ping matches across, so we're in sync. I would put the game time up, but the game time just changes very rapidly. So it's a not so useful type of metric. All right, let's see here. Okay. Now that we know we have the ping, I want to iterate through the players, but also I want to draw a rectangle and a box and all this other fun stuff. So let's go to the UI, and let's actually go to update first. And I'll do game state pointer, so we'll go even further. Game state pointer, we'll do this. Boolean, show player list, false. Nope, we gotta go to our ENET here. Okay, and then GM update. It's right around here. 1, 2, 3. Let's just put it right here. What is that? Player does not equal null. All right, we've got everything we need to jump into that UI rendering section here. Great. And so now I want to render this at the top level. So we'll do and we're going to do just a rectangle. Trap. Draw. Rectangle. And we're just going to draw it right on the screen. And we'll do 50 by 400. Black. And then for fun, we'll do a white border. And we'll do lines. That should look good. And then for int I equals 0, I less than game state pointer player client's length I plus plus. And then we could do trap.draw text. We will do ping. Let's do ping be I, and then I need to actually get the game player client star player cli equals, I get this great dot ping, and then we'll draw this 5 off from the left, and then we'll do 5 off from the top, plus I times 20, and then we'll do font size 5, and we'll make it red. Great. All right, server, client, join, we're in. Server, press tab. Bam, we got it. Ping. So I do need to fix multiple people connecting because we're getting the client not found error, and there's some reason to that. I was using peer ID, but I think peer ID is not enough of a unique identifier, so this is where it's like much more painful. I've tried the other day with multiple people and it didn't work. So I need to do like another level of distinguishing things. I imagined that I could do something like, let's see, ENET. Let's do ENET differentiate players from same IP. There we go. Because that's what the issue is. The great part is, this isn't an AI. This is from 2017. Ah, such a relaxing feeling to have genuine information from people and not regurgitated garbage. I don't know what I'm talking about. I don't like it when people give their like 2 cents and then, you know, but maybe he has a point. Okay, great. Do you want to hold my hand? Okay. Creates a peer for every remote client, and every client you remember each peers that is present to you this way, perhaps by counting a pointer, sorting. Yes, okay, but what if I connect as the same person? Am I getting the same peer? And that's where we're going to need to do this. Here is where you're supposed to allocate your own client management structure and assign it to the data, the peer data field. Each time ENET gets data from a particular peer, you can figure out which peer by looking at this data. Brilliant. I'm going to put client ID in there. I think that'll work. All right, so we call this guy a poopy pants because he, instead of being helpful, he's doing critiques and providing his 2 cents. Let's read the content of his message now that we've gotten beyond him being a poopy pants. Okay. Well, somebody gave me a good answer, and the other guy just kind of complained about things. All right, so client not found. That needs to go on a new line. Client not found. Right here. Okay, so what do we got here? We got send packet to client. We find the peer. What is it going and doing? Client ID, packet. All right, so my understanding is that because they all have the same data, they're being treated as the same peer. So we need to eliminate that behavior. When you initially connect to the server, in here, what I do is I say you're connected, but I'm not setting your peer data. What I could do, I mean, this is like the worst way. I probably need to just pass the information on. Am I doing that here? Yes, I am. And here I'm passing the data on. So what I could do is I could what are we even getting here? Nothing. So I connect. Oh, that's client. Okay. So let's go to server. We get a connect. And yeah, we're setting the peer ID. I wonder if, because I set it up like this, I make it harder. I made it harder on myself. But oh, gnet clients.length, current index. I have everything I need here to set the peer's data field. And what are you? You are a net client peer. And I have final references, last heartbeat. I guess I'm reusing this. Yes, I am. So we're going to attach the client ID to that client here. So okay. And then the peer is data. We'll see. I'm going to look at stop this. Peer. What is your peer? You are a void pointer. Okay, so then we'll do this here. It doesn't need to be a void. Well, no, it is a void pointer for a reason. I made it one for a reason. This data field, we're gonna call you. Okay, so there's a way to turn. Okay, there's a toy, which is alpha to int. So I imagine there's an I to A. So I'm gonna do I to A. There has to be. There can't be a you know what? No. All right, this is a data pointer. I'm pretty sure it's allocated. Okay, so you know what? Just do it. Just do it. No, don't do it. I'm gonna go to the ENET website and just look at their tutorial real quick, because they're messing with that data field. They do this space thing. So client information, just putting hard-coded string here. I wonder. Because you can do a string constant here, but how do we do a formatted string? And I don't need to pass a pointer or anything. I guess this needs to be allocated. Let's allocate it. I feel like it's already present. Okay, this is where being a slight noob has its own problems. It's in lib, standard lib. So we'll just put it in that. Okay, jump back down here and let's do A to I. Great. So now do we have I to A? We do. And then we have the value, which will be the client ID, which we have decided it was current index. Okay. The buffer. There you go. I need to actually... what the radix? What base? Base 0. I don't know. What am I doing? I'm making this so hard on myself. So it's not the end of the world. I'm just gonna do this. Char star malloc size of car times 512. Great. And now I'll do sprintf event here data, and then we can put in the format. And the format will be client ID. Great. And we'll put a breakpoint here. And by the time we get here, we'll know that we have the buffer. Okay, we're in the packet. We're connecting. We've got peer ID. Perfect. Continue. Now, when I do another connection, it should give me a new client ID, which is 1. And now we have different data. So, excuse me. Ugh, gross. Got 2 clients here. He can't move. He can. And the server. Where's the server? This is weird. Client, server. I'm missing a whole user. Let's try that again. No breakpoints this time. Connect. Put one here, put one here. If something disappears, we'll know. Join. I'm in. I can move. I can move. I have 2 clients now. Ah, yes, I fixed it. And they both have different ping. So let's just keep adding clients. And boom, he's here. And we've got another ping. Great. We'll add another client. And we'll just do this to our heart's desire because I figured it out. So stupid. All right. And connected. So let's get the server, which should be this first guy here. We're going to move him over here so we just see the we'll move him over here because we can just see the ping. And when I was moving this, we got negative pings. I imagine that that's because I think it halts when I move it, and that's really bad. So let's always run the game even if the game is not full screen. Just skip rendering. And that's today. And that might even be my next one. Let's do P1. Does that put it? Yeah, it puts it to the top. All right. So this one will be P1. And guess what? Started out the day and I already fixed the 3rd player issue. Done. 3rd player issue. Done. Tab, show the pings. Done. Now we're going to always run the game even if we're dragging it around. And let's move him to the left so we can see his ping go crazy. No? Okay. Because when I did this and I let go, it would sometimes show a crazy number. All right. So next step for me would be to disconnect clients and allow a reconnect. And I could use client ID to help with that. You guys are just going through the wall like that? Oh, it's because you're in it. When you're in the wall, there's no wall. Okay. Whereas here, he gets bounces against the wall. Okay, let's close all these. Great. I'm going to fix the multi-client issue. You always should read the docs. Always should read the docs. Matter of fact, let's just read the docs more. All right. Wow. Wow. Okay. Nope. Back to the tutorial. Just going to briefly look through this and see if there's any like little details. Because data was a little detail. Good. Ugh, I read all this ages ago. I don't want to read it all right now. Disconnected or timed out. Right here. Packet data. That's okay. That's not peer data. Let's do data again. See where they introduce the concept because it's right here. Store any relevant client info. Only the data field of the peer is still valid on a disconnect event and must be explicitly reset. Okay. So the question I have, no. Maybe I could store, no. It'll come back later where we have to authenticate that the same person's connecting again, and that's not hard, really, but it's something to think about. Alright, well, always run the game even if the game is not full screen. So I think the way I would test that is click here, start a server, and just drag this. And does he... No, they don't. See? It stops. Okay, and then if it's not focused, it keeps going. But if I'm the server and I drag my screen, I shouldn't destroy the game for everybody. So we're going to fix that. I'm using Raylib. I'm going to look at its cheat sheet here. And there's like something in here about running the game if it's not focused. Am I using is window focused? No. All right, let's game freezes when moving screen, moving window, Raylib. We don't want it to stop working because of that. That's not it. Support. Continue drawing while windows being resized. I don't need rendering. I need updates. That one. This is window over here. No. You can move your main logic background thread, though. That is, yeah, but that's not what I want. You can't have the server do that. Oh, I really don't want to implement threads. Let's just look at the game update. So while window is should close, is this isn't blocking? I don't think so. No. We're gonna have to. If I have to go like deep on this, I can, but it's may not be worthwhile right now. Okay, so I guess I gotta make a separate thread for the looping. Are you kidding me? Okay. I hate using Google. More. Advanced search. Thank you. Domain. Thread. Therefore, I recommend okay, so then if you have it there in the search results, it's probably one of these like annoying you have to go through every page websites. Yeah, it is. Okay, that's okay. Yeah, you know, I'm rapid. So, unsafe language, great, who cares? Okay, C does suffer when the standard is unclear, especially da 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 da. Rules about alien thread. Okay, so this is just one place. This is undefined behavior. Great. So it doesn't say any. Okay, so there's definitely another place where they have threads. So undefined behavior is here. So flow control, keyword list, reserved list, this, that, threads, C11. Any multi-threaded program threaded C program does not use the C threads are UB. In practice, less per time of POSIX threads. Wow, what is a POSIX thread? Prevalent than C1 threads, and therefore more dependable than C. Recommendation: use POSIX or native threading API. Almost all threading APIs are similar, therefore we recommend any thread. Great, thank you. So that was C11. Let's see, C17, C23, memory model, effective type in C, recommendations, dependable, whatever. Okay, so let's take a look at this suggestion here. So threads, and he said POSIX threads. Okay, I'm not doing a lot of threads, so okay. So he says the recommendation is POSIX or native thread API. So what is the native threading API for Windows? We're gonna have to wrap this, but do interesting. C89 Windows. I don't wanna see what you got here. Okay, well, that's a possibility. No. P threads. I'm not downloading that. Well, okay, this is great. Okay. We're already here. Do I want to add another random header to my project? And let's see how much this has been used. It's not a lot. We'll keep going. Okay. Why do I care? I'm pretty sure I'm already using C11, so let me just look and see what I'm using. Because if I'm using C11, I could just use the threads in that, and then we can put a wrap around it, and then I can put whatever I want behind it later. This was easy to find before. I don't know why I can't search for it. I guess it's per project. So let's look here. It's going to be at the engine level. And then I'm using C14 as the standard, and then legacy, which is all right. Well, there's a chance it just comes for free. So why don't we try it out? T reads. You didn't even spell it right. Is that what's going on? Yeah, he didn't spell it right. He called it T reads. That's okay. Where's the owner of this? Did he abandon his Discord? Might have. He's gonna have the king hat. Okay, you know what? First message in here. I saw it. This guy. At E. Okay, I'm sure he'll fix that whenever he feels like it. Jump down here, threads. Okay, let's go look at threads.h example. Okay, always run the game, da da da. This is now thread, make a thread for the game loop. Well, you just can't have the host have that much power. Just drags his window and like wrecks the entire game. Makes no sense. Okay, so let's read a really bad article on the internet about how to do this, right? I don't want to wait. So we'll look at this one. Use the data. Interesting. Thread exit success. Yeah, so in here, we create a thread. And we're only going to do one. So let's go to main. Fun to do. Write a wrapper. Okay, we'll do one thread. Okay, and then we want to create it. Create. Okay, I imagine that I need to do a little bit more scaffolding here. First, I want to get to this while loop. This while loop is the thing that I want to put into a thread. So we need to take this all out and close that. We'll call this void game loop. And what do we got? Got any errors? Nope. Okay. And I took it out right here. So we'll do game loop. Compile. Game loop. I'll put you at the top. All right, let's see if there's anything crazy going on up here. No. I'm going to add this. I don't know what that is for, but it's here. Cannot open source, so that's not here. There might be a need for thread exit. And that could be the problem. Nope. Okay, so let's do this. Let's jump here. And okay. So I'm gonna just create a new console project and see what it makes. Little baby crying. We'll make a new project and just take a look and see what compiler it's pointing to. Yeah, it's the legacy one, so that's fine. All right, so is it something I have to create? I wonder. Okay, so we'll read through it for the top. Thread exit. Threads. Thread exit success. No, that's not the issue. Is it because I'm using... You know what? Let's look at that. This one. Alright, let's change you to a C. Standard IO.H. Okay, we got the same thing. So now I will just copy this. I feel like this is just a bad example. So yeah, okay. So we're gonna find a different example. Maybe I need to modify my project. Maybe I have P threads. Nope. Ugh. This is like the most huge example. Works. Okay, so let's start figuring out what am I missing. That worked. That worked. Ah, are you telling me that to get threads I need to do windows? Okay. It's not the end of the world. There's a way to get around this. It is that type of wrapper approach that I was talking about before. So I will do something more like that. I already have something where I'm using Windows H for the DLL processing stuff. So if I, in here, yeah, my DLL Windows stuff has it. So I just need to put it in a different thing. And I believe Game Engine uses DLL Win. Yes. Okay, so this is what I'll do. I will define my threads, start my threads with a function here, pass in the pointer to the method that I want to be threaded, and have that be the way I go. Okay, so then I'll just do gc underscore threads, thread. gc underscore threads. We'll do that. All right. So let's go to CMake. All right. So threads. GC threads. And then I will need to change my update loop, which is fine. Right now the game loop has Windows should close in it, and instead that needs to be a Boolean. Wait, no. I'm just doing a void pointer to this thing. It doesn't need to do anything like that, you know? It's always a matter of time before you get one of those stupid bots that come in and do this spamming. You can just ban them. Okay, so I'm going to make the file in the folder. Okay, then we reload all, and we should have threads. We have threads. Great. And I probably could add a header file too. Yeah, I'll add a header file. There we go, threads H. Threads H. Okay, and then in here, let's do DLL win H. So we'll do thread H as well. Great. We now have everything. So we could do include threads. Done. All right. And then the only thing I need is to go to here. Let's just do in here, do include threads H. was in our DLL win. Yes, this is where we do all the dangerous stuff. And here we're just providing methods. So then I would do in here, include thread H, build. And then go back to the main here, get rid of threads H, go to main, get rid of P threads, build, build, build. Okay, and that's in thread H. Why is it in thread H? That's thread H. Build again. How are we getting that still? We would have to look. And it's probably this. Build. We're great. Okay, so now if I take all of this stuff and then I do threads H, problem. Let's do this. Problem. So we'll get rid of that. Build. Done. And let's make that method to create the thread handle and everything. So we're basically doing this stuff here. I'm going to clean this up very quickly. This can stay hidden in here. And hello there, we did that. Exit the thread. Great. Do I really want thread exit? What does thread exit do? Thread exit. What are we? Thread exit. All right, I don't know if I want that, but here we go. We have thread, threads. Looks like there's no threads here, so maybe this is the way to do threads. So let's see what we got here. Standard handle, all this stuff, mutex, close handle, shut down. This is such a convoluted way to do this. It's so filled with stuff. You know, like there's just too much stuff. I need a simpler example of a thread. I don't need this like crazy thing. This might be it. We'll see. I don't think this is it. Thread. Threads in C example. Windows, include Windows. Great. Okay. And click up here. And we'll do include GC underscore threads H. We're good? Launch. So if this worked, we would be expecting, you know, some sort of printing. There's nothing. So right here, test thread, create thread. Optionally do stuff here such as wait on the thread. Okay. That's weird. Okay, we're gonna do oh, it's not a loop. Okay, so while true, great. Thread is going. Let's run that again. Okay, and we're gonna go one step further. We're gonna do int test. And then we can do a test. No, we don't need a static. And then we could do print the, and then we can do test plus plus. Run. Okay, so now I'm moving the window. The thread's continuing to run. Perfect. Next step, we want to have a function pointer. All right. Okay, so instead we need to point. I'm like function method input function pointer C. Just like stalling out on this. Okay, so then this would be I think it goes like that. Nope. Okay, so you can declare one like this. So what if I did void star func pointer? That looks good. Great. And then instead of, that doesn't look good. I did that wrong. What am I doing wrong here? Is it? Okay, here's the actual syntax for one. So I'll do function pointer, and instead of this we do void, and then instead of two ints we would do this. Perfect. We'll call it this. Run. Access violation, reading, blah, 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 blah. Fine. Well, why not just do this? No, that's not how that works. Oh, but you could do this. Like that. Great. And then in here, we could just do that. Okay. And then instead of this, and then we could do GLB func equals that. Really? I don't know what I'm doing wrong then. I want the update to keep running. That's what I really want. I don't need everything else, like the rendering and stuff can stall. So instead of the game loop, I wonder if no. I'm gonna struggle through this. Watch. Okay, let's run this again. Yeah, now that I think about that, that's not really solving what's going on. It's not a common issue, but it is an issue. I might have to come back to this later. I'll leave what I have in, but I won't. I think the next step here is try it again later, but think about what I'm accomplishing here, because running the game loop is great and all, but there's a lot of stuff in here that's Raylib specific. I'm wondering maybe if this is the wrong place for it, and it's would be better in the module. If I put it in the module, what am I doing if I do that? Well, if I put it in the module, that gets me here in DLL main. And I could, when you ENET, I could have this be where you set up the loop, and then that loop no what's happening is when I do an update, that's because I'm running a command from somewhere. Yeah, I'm receiving a command called update. Sending that to the DLL. Well, what we could do, and that other problem is that I'm rendering. I got frame times and all this other stuff. So there's a lot more to solving that problem, which I'd say is not worthwhile at this stage. So I was thinking is like, I have the app, or I would call it the engine, and then I have the module, and then the module's a DLL. The engine communicates with the DLL, sends commands to it, and so I have a lot of stuff over here that's, related to the computer, like inputs and things. Whereas the module is just receiving that information after I've kind of set it up for it. So if I wanted to make it to where the game kept running even though you move stuff around, I could do that. But I would have to... There's like a lot of stuff I'd have to do. I don't want to do it right now. So I will put this on the figure it out later pile. Get rid of that due date. Sometimes you just gotta know when to stop. Alright, I've got some of my big issue items are done. Third player issues done. Tab toggles done. I imagine at this point things will stay pretty in sync. Problem is that there's no way to recover, and so then the players will get stuttering, which that isn't too big of a deal, but it is, I'd say, low quality for this type of game if I let it be that way. So that means I need to actually work on it, but I think I'll run through a round of testing and just get the info from live users about it. Because if what happens is you kill some of these guys, like I could see it, like some of the coins are jumping. And they're jumping because the server, you hit it, the server receives the info about it being hit, and then you get an update, but you don't know as a player right away that it's getting that update. I mean, it should move right away. Oh, it's because we're receiving a packet. Okay, so I'm receiving a packet that's in the past. My game time's ahead of the packet. I should just report every time that I'm receiving a packet from the past. And then tell it to do nothing or to not do that update, if I've sent out something, this is one of those like get out your paint program problems. I was looking at an article the other day about this. It's like here, here, here. So like the diff between here and here is 200. So when I click here and I'm attacking that coin, it should move right away on my screen. I send out the command, the server gets it, it processes it, makes it move. But now it's, in this case, it's like 16 milliseconds. When it gets back here, it's 16 milliseconds behind. If we're on the path to where we need to go, I don't need to change the thing. All right, let's take a look again. Just a quick look here, because look, it scatters, and that's because the server's sending an update. And see that boomeranged. So as soon as the server sends a state update, because here, if you look, this is on the left, this is the right. Left side's the server. Server's going to have the most up-to-date information. So when I attack this thing, it moves on the left immediately. Everything will move immediately. But we're going to send a response with the state of the game back to the user, and it's going to correct things, but it doesn't need to. I think what I need instead is the server's expected position, my position, and then wait a second, go, okay, we're going to ease this back to where it needs to be. So for example, when I hit this here, it stopped and then it teleported. Well, instead you could go, well, you just said you hit it. It's moving, and it's going to end up here on the server. I don't need to give you the past and put you here. Instead, I'll just let it go. So how does that look like? Well, I hit it here. The server is going to send me... what I want to do now is check and see if there's ever an instance where I'm getting information from the past. So let's load a client here and just look at my output. Just see how much stuff the client's getting sent. So the client would be this one. There's nothing here, right? So I'll spawn a bunch of these guys, and when I kill them, it tells me that I freed some things. I'm catching these coins. They're kind of lagging when I get them. I should be getting them right away. If someone else were to get them before me, they'd just disappear, and I wouldn't get them. That's okay. Okay. Why are we increasing the length every time? Am I not, some of them are turning, and then when I pick up all these guys and I spawn a new one, it shouldn't be increasing the length. It should be doing next free. So there's something wrong with the way I'm freeing things in the update code. So the update code, I just need to modify how I'm freeing things. Do I? All right, that's a side quest. See how he's jumping? He doesn't need to jump. So I need to just report the current time versus past time whenever I receive a packet on the client. So I know when I'm receiving that packet and how far off I am is how far ahead the server is versus where I'm at. So that would be in here. So this is my game time. And then the server has its own game time. Oh, sorry, this is server time. And then I have my game time. And that would be last game time. All right, and then... Oh no, this is my game time right here. So I would do printf run that. Do I want that for everything? I want that only for the big packet updates. The ones where it's updating all the units. This one, this game state. And let's do it on a new line. Forget to do a new line, and you got to deal with all the messed up looking data. There we go. Run. All right, great. So here's the thing. I can't at a glance see the diff between the two. That's a somewhat of a significant amount. So when I attack, I want to send out that signal that I'm attacking. So that would be a packet I'm sending to the server. So I'd be client to server, and it would be an attack, and I want to give the game time of that. I'm sending it an update position. Right here. So this is what I'm sending the info. And we don't need server time, we just need game time. Because we're going to get a reaction from the server. All right, and so I'm updating my position. The server then sent me a packet, and then I updated my position. This is where it gets really hard. I'm not opposed to it being hard, but it does get hard at this point. You gotta think more about what you're trying to accomplish. Well, I gotta go read an article that talks a little bit about this. It's one of these. Can't believe I don't have this. That's not good. Alright, well, I have it from yesterday. Just look at my history. Yo, Stamy, how's it going? Making a game right now, and I'm working on the multiplayer code, and I've gotten somewhat stuck, but should be able to fix it. Better approach is to queue the client inputs as without processing. Instead, the game rolls are uploaded periodically at a low frequency, 10 times per second. The delay between every update, that is called the time step. Every update loop iteration, all the unprocessed client input is applied. The new game. Okay, well. Yeah, okay. How's your day going? Client is very sparse information about other entities that may be moving throughout the world. Yes, this is what I want. You can't just update player positions whenever it does that. You get players who teleport. Yes, this is a problem. The key to the solution is to show the other players in the past relative to the user's player. Always showing the user actual movement, except you're showing it 100 milliseconds late. All right, let me slow down and read through all this. Sending deltas. Interesting. Because each player sees itself in the present, but sees the other entities in the past. So the player is always going to see where they actually are in the present. And then they're going to see past data about everything else. Why did he use 100 milliseconds? 100 milliseconds though. Time step. So the server's time step, what am I doing right now for that? I think I'm doing every 100 milliseconds I'm sending out data. So let's look at that game state pointer. This is the time step. Okay, so let's see where we're using this. So the server's updating every 4 times a second. We need to update 10 times a second. All right, so we'll do that. We'll just see what we get with that, and then go from there. Join. And boom. All right. Now I'll spawn a bunch of these things. And go for it. So on the right, yeah, we're still getting a little bit of that choppiness. But it's a little bit faster, like it's harder to notice that we're behind. And all's the every 100 milliseconds would be is getting the data in the past. So if I'm seeing everything in the past, so that went out further. So I'm attacking in the past. So then whatever I do happens at this point, but the data that I've looked at is 100 milliseconds old. So I attack here. So I got to process the packets in order as well, don't I? And what am I doing right now? I'm processing them as I receive them. No, that's not what's going on. I'm processing them um, in a non-queued manner. I'm processing them at the start of a loop. So let's read a little bit more. Try to elucidate some understanding. So delay between every time steps. We have a 100 millisecond time step. Move to the right. Data reckoning. This is one we're looking at. So you receive position data at T1000. I'm assuming that's from someone. You've received it at 900 as well. Who's the you? Is it the server? You can't just update, so you already have 900, so you know where the player was at 900 and T1000. So from T1000 to T1100, you show what the other player did from T900 to T1000. Oh. Interesting. Do I need to do this different? I do. I do need to do it different. I need to include the tick, the tea time. I'm sending a huge amount of updates. I'm sending everything. I don't need to send everything. I only need to send the things that have changed and when they've changed. I only need to send the delta. So I received position data at T1000. So how's the player going to know what tick they're at? The server tells them. So I send an update for 900 and 1000 to the player. They're at tick 1000 already, because they'd be 100 ahead. So I'm showing them the past. I'm giving an update every 100 milliseconds. So the server can consistently keep track of its ticks. And then the client has to decide what tick it's on somehow. I know how to do that. I have the game time, so I could the server can tell me when is the start of a tick. No. I'll have a server count ticks. And then when it sends the info, it'll send the game time as well, but it'll also send the tick. As a client, I should be able to look at the game time, should be able to roughly figure out the tick time. Well, at least I know all this hard work will pay off, because when I write another game, I will have a much easier time keeping track of the ticks and all this other stuff. I'll already have it. I'm imagining this is in here. So this is server time, game time, ping. Really, do we use the ping somewhere? I guess we do. Oh, wow. Well, Sammy, welcome, and thank you for the 10 bits cheer. I don't know what I do when that happens except shout you out. Oh, did I do that way? I think it's shout out. I don't know what I'm doing anymore. Let me actually shout you out, though. That's fine. Thanks again for the bits. I don't really know how they manage that. I forgot I even had Twitch alerts on. It went off. Yeah, okay, I do have it on. Let me keep on this. I'm getting closer to figuring this out. And having the server ticks makes a lot of sense. I'm going to start out at tick 0. But then I want to increment it 1 afterwards. When this is all done, I want to increment the tick. So that'd be after I send the packet to the client. Increment that once. So we start at 0. So now, run the server, start. Yeah, I do this every time. Working on homework. It's always good. There we go. There's the tick. So I have the ticks. So then if I have the server ticks, I need to like store a certain amount of them. If the player is always ahead of the server, then it's the client that needs the server tick information. So when I send out info, I would want to give the tick number. And then what happens is that the client can simulate between the first tick and the next tick So then if there's enough of a difference between the information there, I would want to correct it, but I don't want to force the correction. So I could put some sort of, oh man, the reconciling of past to present tick stuff is going to be a fun task for sure. Okay. Everything the player's receiving is from 100 milliseconds ago, but we're going to show that past thing to them. You know, I've seen this kind of happen with like League of Legends, where you join and it like runs like the past 30 seconds really quick. It's because I think it's actually sending you the tick info. So I gotta ask myself this question: it's like, how expensive is it to store all of that? I could imagine that would grow big fast. So that's probably not it. No, it has to be. I think you would store like the past maybe 60 ticks. And then that would, well, I mean, you don't even need 60. You only need like maybe the past 10. That's probably too much as well. So let's see. Player inputs lead to player results. When I hold down the right movement button, the player moves to the right. Right now, I'm just sending the player's position to the server. But what we really need to do is send their input to the server, simulate the input on our end, and then let the server do the updates. I'm only a little hesitant to move forwards on this because what I'm thinking is going to happen as soon as I do that, we're going to experience like this like mini lag or something. So let's see. I just don't want to introduce that yet, but let's see here. Not mini lag, sorry, I'm just like half brained right now. Let's check this in. What is going to happen is that I'm going to be pulling out some code. It's going to remove some things, and then I got to add it all back. What I think I could do is I could send relevant user inputs, which would be move right, move up, move down, move left, and then the clicking of the attack. The server, or sorry, the client, so this would be the commands that they're sending. The command is I want to move. And so I could send that as frequently as possible to the server, giving them the most up-to-date information. Because I'm showing the pass to the player, that means I have a fully accurate version of the player's movements. When I send stuff to the server, I need to have it be in order. So I'd want to have the packets in order, which is okay. It's not hard because I'm sending the game time. What I would want is packets order. So Yeah, so then I would be able to simulate all of their movement in order. I'd be getting their state, but I would have the detailed details about their state, right? Because we could show what they did from here to here, this tick. Ah, yes. Okay, I get it now. You have the details of that entire tick, but you've received a whole 100 milliseconds of information from the player during that tick. So you would show all of that to the player, so the player would receive all of it. So what I would need to do is show all of that. So there's let me get back to this. There's two different types of things going on here that need to be looked into. One is the monsters and the objects in the world and its movement, which is pretty easy. You'll just send the increment for all of that. And then the players is where stuff's weird. So if I'm running around here and there's a bad guy, I kill him, he spawns stuff. It shows up pretty quick. Like the server knows right away when something's getting hit and killed. And it interacts or reacts to it quickly. That's great. But there's a few instances where you kill something as the client and you get that stutter. That stutter is happening because the server is simulating your commands. Like it receives it right away, but I'm not showing. Okay. For players, you'd want to simulate everything so that the player movement looks good and doesn't have any choppiness. So to see that potential choppiness, I'd actually have to go as a client because the server's receiving stuff. So I have two clients now. Client and client. So he's got some choppiness. And the reason why I know that's true is because if I go in as the server, this is the server, and I move around, he looks smooth over here on the right. Very smooth. That's good. I can actually do a test with this. So he's smooth, and then if I go and I take this guy and I put him on the right, there is kind of this like, you can, oh, you can't see it because you need to be on the left side of this white line. So let me move them over here. So I could press a key and make it do it automatically where they would just patrol. But this guy, he looks choppy when he moves, which you can barely see the choppiness. If I change the update frequency to a quarter, you would see the choppiness. So what's happening is we're not, like there's no like command on this guy. I guess there's velocity, but we're simulating that changing. So if this guy here, he moves smoothly. And that's because his full velocity, no, that's not what that is. So he moves smoothly on the right here. Let me put my mouse where it matters. Right here, this guy, he moves smoothly. And I can see it better on my screen than maybe you can see on the stream. But then when this guy moves, he's got some choppiness. Maybe I'll just make F be patrol up and down. And then you could see it. I'm not going to program that. That's annoying. Let's just do it. Okay, so the F key, I'm going to make the F key make you patrol. I don't want to do that. I really don't want to do that. But I think it's useful for the testing, so let's just do it. Here. If key pressed. Okay, and then we get to starting position. The goblins have a patrol point, so I could probably piggyback off of that entity thing. He has, where is it? Destination toggled. Yeah, there it is. So I could turn that on. Okay, so that's for goblins. No, no. Because then you've got non-player input based updates. No, we're just sending the player's position, so this would work. Okay, so if we've got this and non-player AI, how is that? Where do I have the player? Yeah, I don't think I have that there. Yeah, so we'll just do if source entity type ID equals entity type king All right, great. And then we have destination X, destination Y. So we'll set that when you press the F key. Okay, and then we'll do destination will be position.x equals, no, destination.x equals all right, that should just work. Okay. You're just going all the way over here? Okay. Oh, yeah, because you copied only half of it. You need to copy the other part. Okay, so it's going to be destination toggle, and then we're going to do if source and patrol take you to you, paste, start, and F. Good. So now we can do server. Actually, nope. Got to get the server lister up. I need to make the server lister be hosted, so I don't have to keep remembering to do it properly. Okay, join. And here you are. You're going to stand on the white line. Press F, and then you're going to stand on the white line. Press F. And let's... There we go. They kind of... There we go. And then we get one more client in. And we do that. Okay, and then let's kill this thing because he's annoying. Okay. So the top one is the client, and the bottom one's the server. And on my screen here, he's smooth, and the guy on the top's just slightly choppy. And is he always stopping at the same point? Looks like kind of like that. And then you're stopping. All right. What happens when the server thinks you're somewhere else? I guess you would have to reconcile that a little bit. Let's see. Oh, let's change that to a way bigger number, because then I'll make it easier to see what the issue is. There we go. Yeah. All right, so if I receive an input that the player is holding down a key, and then they lift up that key, and then the player 2 witnesses that, he's going to see when that stops. So right now I'm sending position and velocity, but instead I could be sending key presses. All right, well, that patrol code's not going to work once I do this. And I'll have to actually simulate the key presses. Something else, I'm going to want to have a buffer into the past of, say, the past past 2 or 3 ticks of player input. Which means I would probably need to increase my buffer size for the keyboard to allow 100 commands. That's a big buffer, not a too big of a buffer. And then I would want, what else would I want? I'd want to let's just think about the commands real quick. So I have mouse movement, which informs the placement of the orb. It's based off of where the mouse is of that player. So that would inform that. And then you click. And it's like, well, do I need clicks? I need clicks for attacks. So then I would say, well, this person's doing an attack. That's what they would be telling me. I did this thing. So when I say, oh, move to the right, they need to be sending a movement command. I don't need to send key commands. I need to send movement commands. So the idea is that every update, I would be sending a movement command. So then those would get queued up. So here we go. We've got all our keyboard stuff. We do things. And instead of sending to the server, my new position, I would send that I tried to move to the right. That would get queued into the packet stuff. But then in here, I have code that checks and says, well, okay, you're tried to, but you're not going to. Well, the movement to the right is about velocity and the speed ups, this stuff. So those commands would tell me that, oh, the player needs to move. So I guess I could iterate through. I would receive a list of commands for the past 100 milliseconds. So I would have them all stored in some sort of buffer that I could clear out. I don't need to clear. Yeah, I could clear out. I would know the start of the tick and the end of the tick. So I could actually include the tick as part of the command. And then loop through that a bunch. Then the server would have to simulate what's happening, and so does the client. And the client can simulate what's going on from what it receives from the server. So then the player could do stuff on his end, and he would have what they did in the past, but we would be playing what they did in the past. 100 milliseconds ago, but we're always receiving past movement data from the player. So then they're always just pretty close. Then we get the past 100 seconds, we process or past 100 milliseconds, process those, and we keep going. So then we're always showing the past to the player, and the players are always working with now. So what they're doing is they're interacting with, the player would be interacting with 100 seconds in the past, but all the player's inputs would be happening right now against that 100 milliseconds in the past. So everything would seem smooth. Yeah, this would work. It's a big old brain work on this one though. And I'm reaching the end of my stream time for today as well. So I'm thinking, instead of, I guess I have to have another set of things here, but I guess I would look through. I mean, the way I'm doing it right now is it just happens immediately, but that's on the client side. But I would need to do this. So then this is client or server, so player inputs, and then I would have down here to do work through the past ticks updates. So that would be the thing. I would receive something about the no. I would receive the ticks. So then I would receive the movements and everything from 100 milliseconds ago. There wouldn't always be stuff in this. And I could process them. I could process them the way that I process the other stuff. So I could do like, okay, we say tick time is right here at this one. My local client is at that one, and I have an item at 2715. So then next time I come around, I'm at 2720, and I can do 2715s, simulate, and then that would get me to a very nice looking thing. I guess we're buffering basically by 100 milliseconds, and then that could allow the server to do the whole, you hit this, they hit this, what really happens, and then we could correct. Man, this is gonna be a big pile of whatever, but this, like, having to think really hard about this is like the process of learning how to do this right. So let me go read through this one more time. Yep. Got it. Okay, so the reason why you can't do it the other way is because of the jumps. This would all cover the jumps that I'm seeing with the player. But what about the jumps that one would see with the server? And the objects in the server, because I guess we could do the same thing. Now, if I attack a monster, I want to see the results of that attack immediately. So I attack him and he moves immediately. There's no way to do that. So it would be better off to not send authoritative updates about about this stuff. Or no, it would be good to send authoritative updates, but ease towards the correct state. Because what could happen, yes, this is right. Okay, so what could happen is I could hit one of these guys on the right here, I could hit him, and then I kill him. And it's like bouncing the things back, but on the left here, they don't bounce. I could just, like, it's going to be the same thing. I'm going to get an input at a specific game time. It's going to simulate it on the server. Problem is that you just receive a packet like 1 second too early. Like if I can time it, yeah. So you receive it 1 second too early, so then it like undoes what you did. And then since your end, you're like, oh, okay. So like I already hit this thing. It's supposed to move, but we undid what we did because the server sent an update before. Like I trigger the attack, the server sends the update, and it's like moving. I attack, on my screen it moves. The server receives the signal that I've attacked. It processes that I've attacked on its end. It sends me an update before that happens and moves it back. It's now next to me and it didn't move. How on earth? How on earth? We're going to have to keep hitting this until it happens again. Because, yeah, right there. I hit it. It was going to move, and then it jumped backwards. So there is some sort of time lag. But the thing is that I shouldn't be influencing the server's position of this thing. I can hit it, and it'll move, but it shouldn't be doing this whole like teleport backwards when you get hit. Because the server's still going to hit it. That's weird. Anyways, it's moving a lot faster because of some things, but maybe what's happening is I'm moving a little bit and hitting it, and it's, yeah, that could be what's going on. I'm like just out of the range, and there's like it's a velocity bug. So on my end, it doesn't think I've hit it. So I could tell the server that I hit it. That's what we'll do differently, is report what we thought we hit. That's what we would do. And that's what's happening. Okay, so then for if that is reasonably possible, aka if they did it on their end and they are only slightly off on the distance, then let them have it. The threshold should allow for the best player experience. Okay, so that's what's happening is because the player's movement is a little choppy, when it's being simulated on the other side, its velocity is just off a tad. So the server simulates that velocity being off, because what's happening right now is I'm giving them velocity and movement data, but there's a moment where it may not receive that information. It simulates on its end and decreases my velocity, so then I'm not moving as fast. But I had the button held down, so there's no reason for it to receive a period where I didn't have the key pressed. That's the problem. Okay. And then I've seen this happen before where the server assumes that you have your buttons pressed until you don't have them pressed. So I need to send commands of what I'm doing. So I do need to send the key commands. But I also need to I need to tell the server what I'm doing. So my right movement's down, but if I don't let go of it, then I'm going to be assumed to keep going to the right. And then maybe it's just worthwhile to always have packets send what my stuff's doing. But then you could get into those weird situations. Okay, I have so much stuff to work on now. Um, all right. Thank you for watching today. This week I did not have as many streams as I normally do. It's been a busy, busy week. But I plan to stream more next week. Thanks for showing up today, and I'll see you probably sometime during the week this coming week. Okay, see y'all later. Have a good one, and we'll keep on moving along. And today, just so you could see, we fixed the third player issue and some tab toggling. We have a little bit of netcode stuff that we've added. I'm probably going to spend some more time on this today and see if I can have this done, actually. It'd be nice to have it done for tomorrow. But things are working so much better. I'll keep working on everything else, and then we might actually have a really neat game. So